Alright, this is lesson 36 for 8th grade, and today we're talking about multiplying and dividing integers and terms. And more specifically, we're talking about algebraic terms, which we'll get into. Just want to say that this is pretty important stuff because it's definitely going to relate to algebra once again. So, remember a few lessons ago we were adding and subtracting integers, and integers are, again, our positive, negative numbers, well, basically all our counting numbers, and then all the opposites of those. So, like 1, 2, 3, and then all the opposites of those, -1, -2, -3, and then 0 is included in there too. So, that's what we're dealing with here. We had certain rules when we added integers and subtracted integers, and now we're going to have certain rules when we multiply and divide integers. So, main goals here, we want to learn those rules for multiplying and dividing the integers, and we're going to use our knowledge of exponent laws to help us multiply and divide algebraic terms. So that'll be the last thing that we talk about. My board has not been racing very well lately. Alright, so let's look at what we've got here first of all. Alright, so we have a number line here, and we're going to illustrate multiplication and division of integers. So, first of all, the arrows here are showing us that 3 times a -2 is -6. Okay? We are going to show shortcuts for all of this. But basically what we have here on the number line, remember we always start at 0, and we have 3 -2's. So one -2, another -2, and another -2. We're basically adding 3 -2's together, and that gets us to -6. So this tells us that 3 times -2 equals -6. And the illustration also shows that if we divide -6 into 3 parts, each part is -2. So that tells us that -6 divided by 3 has to equal -2. So looking at these divided into 3 parts, we can see -2 for each section. That would be -6 divided by 3 gives us a -2. And likewise, the illustration shows that the number of -2's in -6 is 3. So it's kind of manipulating this equation around to show us that -6 divided by -2 should give us 3. Okay? Basically, if we were to divide by -2 on each side of the equation here, we'd be left with 3. Alright? So, from these illustrations, this is what we should notice as far as the relationship goes. These rules are much easier to follow than the adding and subtracting. I think they're a little easier to remember and work with. If you're multiplying different signs, you're going to get a negative product. If you're dividing with different signs, you're going to get a negative quotient. Okay? So different signs with division, get a negative quotient. Different signs with negatives, or different signs with multiplication, you'll get a negative product. So basically, if one's positive and one is negative, and you're multiplying or dividing, you'll get a negative answer. If you have the same signs when you divide or multiply, you're going to get a positive result. So if you have the same signs when multiplying or dividing, you'll get a positive quotient. So that could be 6 divided by 2. It could be -6 divided by -2. You'll still get 3 either way. So here, to follow up on what I said, we multiply two negative numbers like -3 and -2. We can think about the multiplication as the opposite of 3 times -2. Since 3 times -2 is -6, the opposite of 3 times -2 is the opposite of -6, which is +6. So, same thing, same signs when multiplying, you'll get a positive answer. And just to show you, you could also have same signs as positive. 6 divided by 2, you'll still get a positive 3. -6 divided by -2, that also gives us a positive 3. Same with multiplying. 2 times 3 is 6, but -3 times -2 is also 6. And we're going to notice some things about that coming up here in a second. So if we want to simplify these real quick, A, B, C, and D. We have, first for A, negative 10 times negative 5. First thing we're always going to do is multiply the numbers together. 10 times 5 is 50. Now we have to decide what sign we're going to get. Well, we have a negative and a negative. The signs are the same. We're multiplying, so we're going to get a positive 50. Okay? Now, B, positive 10 times negative 5. Well, multiply our numbers first. 5 times 10, 50. And we have different signs, so we're going to get a negative. Alright, C. Same signs, we should get a positive. 10 divided by 5 is 2. And lastly here, positive 10 divided by negative 5. Different signs, we're going to come out negative 2. Okay? Excuse me. Now, I want us to remember that when we get two negatives, when we're multiplying, yes, we get a positive. Two negatives, when we divide, yes, we get a positive. But two negatives doesn't always mean we get a positive when we think about adding. Remember, negative 2 plus negative 3, that still resulted in a negative. This is negative 5. We started at negative 2 degrees and then we dropped 3 more degrees, we're at negative 5. Okay, so we have situations with adding integers where we could still get a negative. This is what we worked on not too long ago. But whenever we multiply or divide by two negatives, we will get a positive. So just keep the differences in mind. And I know it's a lot to take in, but once you get those rules down, algebra becomes much easier. Alright, let's take a look at this one. Every month, $25 is automatically deducted from Newton's checking account to pay for his internet service. So write an expression using integers that shows the effect on Newton's account of 6 months of charges. Okay, well, $25 is automatically deducted from his checking account. So every 6 months, well, let's see, so that's every month, I would assume. Yep, every month. Now we're on to write an expression using integers that shows the effect on his account of 6 months of charges. Okay, so he'll have a starting amount in his checking account. We're going to deduct $25 each month, so that would be 6 times 25. But we can think of 25 as a negative amount because it's being deducted from his checking account. So if we do 6 times negative 25, we should get, let's see, negative 150. So on his statement, if he gets a statement for a bunch of different months, we would probably see a negative 150 on there because that's what's being deducted from his account. Okay, check my time quick. Alright, now we're going to use this product rule to help us save some time here in the future. Alright, since the product of two negative numbers is a positive number, squaring a negative number results in a positive. Now remember, if we square something like 3 to the second power, that's 3 times 3, that gives us 9. Okay, it's no different with negatives. We're going to take whatever's inside here and multiply it twice. Negative 5 times negative 5, and we know that two negatives multiplied together gives us a positive. Now let's take a look at cubing a negative. This results in a negative answer. This is negative 2 to the third power. Negative 2 times negative 2 times negative 2. And as we could notice, we know that if we multiply negative 2 and negative 2, we're going to get 4. So these two multiplied together, we get a positive 4. But then we still have that negative 2 left over to multiply by. Hello, student waving at me. And then at this point we have 4 times negative 2, and the product of 4 and negative 2 is negative 8. Okay? So positive times a negative at that point. So we actually have a rule for this. Okay. Notice, I'll go back to the screen. We have a even exponent and an odd exponent, 2 and 3. And for the even exponent, we got a positive number. For the for the even exponent, we got a positive answer, and for the odd exponent, we got a negative answer. All right, so if we can sum this up here, basically, if your negative number is raised to an even power, you'll have a positive product. If your negative number is raised to an odd power, you will have a negative product. So we could have negative 2 to the 4th power. That would be positive 16. If we had negative 2 to the 5th power, it would be negative 32. So even or odd will determine whether, even or odd powers will determine whether or not we'll get a positive or a negative product. And I throw up a little caution sign here, excuse me. Your negative sign must be inside the parentheses for these rules to apply. So for instance, if the negative is on the outside, this square is not being applied to that negative 2. So this means 2 times 2, but our negative is still out there, so we get negative 4. Notice the difference between this and this. The negative is inside the parentheses here. This means negative 2 times negative 2. Here the negative is on the outside of the parentheses, so this means negative 2 times 2, we get negative 4. Okay? So just be aware of that. So let's simplify this real quick. So for A, we have negative 1 to the 5th power. Well, what we really have here, if I were to write it out the long way, is negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Now I know that I'm going to get an answer of 1, I just need to know what sign that will be, because this really means 1 times 1 times 1 times 1 times 1, and then we got to pay attention to the symbols. So multiply these two together, I get a positive 1. Multiply these two together, I get a positive 1. And then we're left with that negative 1 on the end there. So now we have 1 times 1, which is 1. And then a positive 1 times a negative 1, we'll get a negative 1. Okay? Now, shortcut says we could have just taken 1 to the 5th power. So 1 times 1 times 1 times 1. I think I said that enough times. And we should know that we're going to get a negative answer because this is an odd power. Okay? Odd power will result in a negative answer if we have a negative inside here. So this is an even power, we should get a positive 1. Okay? That's the difference between those two. I may have to split this video up into 2 parts. Let's see what we got coming up next here. Yep, I'm going to start this one on the next video. Okay, so stay tuned for part 2.